They are some of the most mysterious and spectacular phenomena in the Arctic, giant craters that appear suddenly and violently, leaving behind gaping holes in the frozen ground. They are found in the remote and vast region of Siberia, where the permafrost covers the landscape and where the climate is changing rapidly. They are also a source of curiosity and concern for the scientists who study them and for the people who live near them. What causes these craters to explode, and what do they mean for the future of the Arctic and the world? The Siberian craters were first discovered in 2014 when a helicopter pilot spotted a huge hole in the Yamal Peninsula, a region that means the end of the world in the local language. The hole was about 20 meters wide and 50 meters deep and had a dark and jagged rim. It looked like a bomb had gone off or a meteor had struck. The news of the discovery went viral and sparked a lot of speculation and interest. Was it a natural phenomenon or a man-made one? Was it related to the oil and gas industry or to the alien activity? The scientists who visited the site soon ruled out the more exotic and unlikely explanations and focused on the more plausible and probable ones. They found that the hole was not a sinkhole or a collapse, but an explosion or an eruption. They also found that the hole was not caused by a volcanic activity or a seismic event, but by a gas release or a gas blowout. They also found that the gas was not methane or natural gas, but a mixture of gas and water, or a gas hydrate. The investigation and the exploration of the Siberian craters revealed that they were not isolated or unique events, but part of a larger and more complex phenomenon. The researchers discovered more craters in different locations and sizes in the Yamal and Gidan peninsulas and in other parts of Siberia. They also discovered that the craters were not static or stable, but dynamic and evolving. They observed that the craters changed shape and size as they collapsed and expanded, and as they filled with water and ice. They also observed that the craters emitted sound and light as they exploded and erupted, and as they released gas and heat. The researchers also collected and analyzed various data and samples from the craters and their surroundings. They used satellite imagery, aerial photography, drone footage, and ground surveys to map and measure the craters and their distribution. They used geophysical instruments such as seismometers, magnetometers, and radars to detect and monitor the craters and their activity. They used geochemical and microbiological methods such as gas chromatography, isotopic analysis, and DNA sequencing to identify and characterize the gas and the organisms in the craters and their environment. The hypothesis and the model of the Siberian craters is based on the idea that they are caused by the decomposition and the destabilization of the gas hydrates, which are ice-like structures that trap gas molecules, such as methane, in the permafrost. The gas hydrates are formed and maintained by the low temperature and the high pressure in the deep layers of the frozen soil. The hypothesis and the model suggest that the gas hydrates are disrupted and released by the warming and the weakening of the permafrost due to the climate change and the human activity. The hypothesis and the model also suggest that the gas hydrates are accumulated and pressurized in the shallow layers of the soil until they reach a critical point, and then they explode and erupt, creating the craters. The hypothesis and the model of the Siberian craters is supported and challenged by various evidence and arguments from different sources and perspectives. The supporters of the hypothesis and the model point to the geological and climatic conditions of Siberia, which are favorable and conducive for the formation and the release of the gas hydrates. They also point to the experimental and numerical simulations, which reproduce and predict the behavior and the effects of the gas hydrates. They also point to the historical and cultural records which indicate and describe the occurrence and the impact of the gas explosions and eruptions in Siberia. The critics of the hypothesis and the model question and doubt the validity and the reliability of the hypothesis and the model, and propose and explore alternative and complementary explanations for the Siberian craters. They question and doubt the assumptions and the parameters of the hypothesis and the model, such as the amount and the composition of the gas hydrates, the temperature and the pressure of the permafrost, and the timing and the mechanism of the explosions and eruptions. They also propose and explore other factors and processes that may contribute or trigger the formation and the release of the gas, such as the geological faults and fractures, the hydrological flows and cycles, and the biological activity and decomposition. The Siberian craters have important and serious implications and challenges for the environment and the society in Siberia and beyond. They have implications and challenges for the climate and the ecology, as they affect and indicate the state and the fate of the permafrost, which covers about a quarter of the northern hemisphere and which stores about twice as much carbon as the atmosphere. They also have implications and challenges for the economy and the security, as they affect and indicate the risks and the opportunities of the oil and gas industry, which operates and invests in the Arctic region, and which provides and consumes energy and resources. The Siberian craters also raise and pose various questions and issues for the science and the policy in Siberia and beyond. They raise and pose questions and issues about the causes and the consequences of the craters, such as how many and how often they occur, how big and how dangerous they are, and how they can be detected and prevented. They also raise and pose questions and issues about the management and the governance of the craters, such as who owns and controls them, who monitors and regulates them, and who benefits and suffers from them. The Siberian craters are one of the most mysterious and spectacular phenomena in the Arctic and in the world. They are the result and the manifestation of a complex and dynamic interaction between the gas and the ice, the earth and the sky, the nature and the human. They are also a sign and a warning of a changing and challenging Arctic and world where the old and the new, the stable and the unstable, the predictable and the unpredictable coexist and collide. This is the story of the Siberian blast, how hot gas may explain the explosive craters.